This is the February 2023 Research Quarterly. We're going to be giving you a 2022 research and review. I am Faye Minty, AP Hero Mom. And Will, do you want to introduce yourself?
Sure. I'm Will Norris. I'm the dad of an AP Hero, deletion.
And we have Ethan Perlstein, who is, Ethan, can you tell us what you do at Prolara? You are the CEO, is that how we?
I'm the CEO of Prolara, but I think in today's capacity, you can kind of consider me research director at Project AP.
Perfect. Excellent. So let's take it away. So the research roundtable started in May 2022, and the first brave volunteer from the research community, the AP research community, was Dr. Nicoletta Moisoy. So she's at a university here in the UK, in Leicester, De Montfort University. She looks at mitochondrial dysfunction, and she's looking at that in our AP Heroes. So her objectives are to understand the role of mitochondria in AP pathobiology, to identify pathways for intervention, to validate assays for through high throughput drug screening. And I think one of the important things to kind of make sure everyone understands is that the mitochondria, the part of the cell where the sugar and the oxygen are converted into ATP, and those are the energy units per cell. So we all know our AP kids have issues with energy, and that's going to affect their ability to function. And so Nicoletta is looking at that. And Ethan, can you tell us what she shared with us in her research roundtable in May?
Sure. So Nicoletta's lab is able to look at skin cells from AP Heroes, compare them to age-matched cells from healthy donors, and they were able to assess mitochondrial function, and were able to show that there are differences between the AP Hero skin cells and the reference cells. And that's exciting because we can exploit that difference to try to find known drugs that can basically convert the AP cells back into normal looking cells.
Brilliant. Okay, June.
So in June, we had Dr. Matt Might and Alexandra Fokinska. I apologize if I don't pronounce the name correctly, but Ethan, can you walk us through kind of what they were working on?
Yeah, so they're coming from University of Alabama, and they have a really cool piece of artificial intelligence AI technology called Medicanron. And they can basically do a drug screen, but instead of in the laboratory, they can do it in the cloud, so to speak. And they were able to look at 7 different genes on chromosome AP. I know that's not all the genes that are implicated, but they were able to look at those 7 and do what's called computational screen. So they looked in the literature of published papers to try to see, are there any drugs that affect those 7 genes? And unfortunately, they weren't able to find anything significant that we could act on, but there's a lot more AP genes we can examine using this tool. And so we're hopeful that maybe we could get a better outcome the next time we try.
And the main advantage of this is that this allows us not to just be completely shooting in the dark. We can be a little bit smart about where we try to move forward on potential repurposing. Is that right?
Exactly right.
Perfect. So in July, we heard from Dennis Lau from the Cleveland Clinic, and he has set up the neurodevelopmental disorder copy number variant portal. And this is an educational resource for patients, for families, for clinicians. And it's a central hub for researchers to explore interconnected data. So have you got anything more to share about that, Ethan?
So the portal is still a sort of a work in progress, but we hope that it's going to kind of be this one-stop shop for data that researchers or clinicians or families can access, and they can explore the data and potentially make connections and bring insights to attention, to researchers. And this is something that could happen not just for AP, but across these copy number variants. So yeah, stay tuned for more as this portal gets filled with more data.
Absolutely, and that data will be coming in part from the registry. So if every AP Hero family is filling in that registry, you're helping your community. Thanks.
Exactly right.
And just that last one, I think is really interesting because it's potentially hugely helpful, because it really allows a lot of different researchers to potentially leverage the information that we're gathering, which means we're going to have a lot more eyes working on the problem set. So this portal has it's a real sort of multiplier effect potentially for the scientific effort that we're trying to do. So the next one up is RAA Warm Flash. And this one I'm going to need your help on, Ethan, because this is the science at the edge of my understanding. So why don't you walk us through what he's been working on with his team? Over.
Yeah, so RAA's team is taking stem cells from AP Heroes and trying to recreate early development. So when you have an early embryo and you kind of are going from that first fertilized cell in the normal case and having all these cells be created in a very rapid time, and then starting to create these patterns or arrangements that you can kind of see with these colors here representing these different types of cell lineages. And so already we can see that there are differences in the way 8P cells, that their earliest embryonic stem cells and tissues are arranging themselves in three-dimensional space. And that could helpfully teach us something about what's going on in those earliest moments of neurodevelopment.
Good. And in September, we met with Dr. Allison Moutry, and he is at UC San Diego, looking at brain organoid models of 8P neurodevelopment. Ethan?
Yeah, so what's exciting here is you can hopefully see the connections between our different research projects. And so Allison's lab is growing these so-called brain organoids, and this is happening over months. Many months, up to 6-9 months even. And what we're already seeing are that the brain organoids formed from an AP hero compared to their parents, the AP hero organoids are smaller. And there's other differences we're already observing as well. So we're very excited for this avenue of research, which again, we hope will connect back to some of the other research that's happening, for example, in Professor Warmflash's lab.
And in October, we had a presentation from Dr. Hirui Maharina, to make sure I got that pronunciation right. Again, I apologize. But can you walk us through how some of the work that he's been doing with Trisomy 21 might apply for some of our 8P folks?
Yeah, we're really lucky to have someone like Hirui join the 8P team. He brings a lot of experience understanding how trisomy 21, how Down syndrome comes to be. So what we call pathogenesis, how the disease unfolds across tissues over time. And he's going to be applying a lot of the techniques he used for trisomy 21, applying them to 8P. Those experiments will be getting underway shortly, as soon as his lab is able to get access to a biobank of stem cells that have already been processed and generated from AP heroes. But we could always use more.
Brilliant. In November 2022, we heard from Scott Demarest, and he is at Children's Hospital in Colorado. If you could tell us, what you took from it, Ethan, that would be absolutely brilliant. I will say that I think this is the one research roundtable that for all the families, if you want to learn more, you should definitely go and watch the full research roundtable, because this is accessible to everyone. This is the clinician's perspective. And I certainly found it interesting when he was talking about cortical visual impairment. Like, that was sort of something I haven't heard before. So I'd encourage anyone who's interested to watch it. But tell them, what did you take from it, Ethan?
Yeah, I think from everything we've seen, the more numbers we have, I think there's this strength in numbers, and that applies to data as well. And that is data coming from models we create in the lab or from AP heroes themselves as sort of living laboratories. So we hope that Dr. Demarest and other clinicians will continue this effort that's already underway to collect samples, biospecimens, collect natural history study data, help standardize the questions and the markers that are being used across different studies potentially, and then ultimately establish what we call genotype-phenotype relationships, which is sort of a fancy way of saying, if you have a particular set of breakpoints or particular inversion duplication inversion, what will that mean in terms of how that presents as disease? And hopefully we can start to build a relationship between, does this, is the breakpoint at this location, and do you therefore see these types of phenotypes? It's not going to be a perfect science at first, but the more numbers we have, and so starting with 15 last year, you can start to see signals like a common clinical feature like cortical vision impairment. But the more samples we have, strength in numbers, the more we'll be able to establish these connections, which will also lead to ways that we can now rationally develop therapies to address those fundamental defects. So please, again, contribute more samples. Sorry, that was my reminder there. Please contribute more samples and we'll be able to have stronger data.
Yeah, just the big picture of all this is, we're trying to use these efforts to really get a better understanding for how things work, what's going on with our kids, and that's ultimately to the goal to help improve their lives and to make life better for them. So just, another big picture takeaway, there's been a lot of work that was launched in 2022. I think it was an exciting year. I think it made a lot of great traction on the scientific front, and I think there's going to be great things to come. So thank you, Ethan, for the work that you've been doing for 8P, and I think we're off to the races. And I think this is exciting. And we as families are a big part of this because it's our contribution of this basic feedstock that goes into all this knowledge that allows these folks to be able to understand more about what's happening, why it's happening, and then ultimately, what can we do to make it a little bit better for folks?
Absolutely. Well said. Well, thank you very much, Ethan.
Thank you.